Today we are going to discuss the topic superconductors. What is known as superconductor? It was proposed by H.K. Holmes in the year 1911. Okay, when he cooled the mercury below the room temperature, that is at 4.2 Kelvin, the resistivity suddenly falls to 0. Okay, that temperature is called critical temperature. It is the normal state of mercury. It is a superconducting state of mercury. Okay, here observe that when he cooled the mercury below the room temperature, that is at 4.2 Kelvin, the resistivity of the material suddenly drops to 0. Okay, that is called superconductivity. That means it gives 0 resistance. Okay, based on the magnetization behavior, the superconductors are classified into 2 categories. First one is type 1 superconductor. The second one is type 2 superconductors. Based on magnetization. Okay, when the superconductor is placed in a magnetic field, in this type 1 superconductor, what happens? It's a magnetic, axis in magnetization, axis in magnetic field, applied magnetic field. When the magnetic field is increased, the magnetization also increased. At a particular point, then it suddenly dropped. That field is called critical magnetic field. Okay, in this superconductor, when the magnetic field is increased, the magnetization is also increased up to certain limit only. Okay, after that it suddenly dropped. That field is called critical magnetic field. It is denoted by Hc. Okay, in this type 2, it's a magnetization, it's a magnetic field. In this type 1 superconductor, this is a type 1 superconductor. In type 2, when the magnetic field is increased, then magnetization is also increased up to certain limit only. Then it is gradually decreased and comes to 0. Okay. Here there are 2 critical fields. The first one is Hc1. Other one is Hc2. What is the critical magnetic field? The minimum field required to destroy this superconducting property. Okay. Up to this, it behaves as a superconducting state. Then one more state is here, that is mixed state. After that is a normal state. Here, up to this is a superconducting state. Then the superconductor, besides super property, that comes to normal state. Okay. Based on magnetization, they are classified into 2 categories: type 1 superconductor and type 2 superconductor. Okay. In this type 1, when the magnetic field is increased, the magnetization is also increased up to certain level. Okay. After that, it is suddenly decreased. That is denoted by Hc. What is the critical magnetic field? The minimum field required to destroy the superconducting property. Okay. Up to this, it behaves as a superconductor. After this Hc, it acts as a normal conductor. Okay. In this type 2, when the magnetic field is increased, the magnetization also increases up to Hc Hc1 only. Okay. After that is gradually decreased. When the magnetic field is increased, the magnetization is gradually decreased, then reach 0. That point is denoted by Hc2. Here there are two critical magnetic fields, Hc1 and Hc2. That it is called mixed state. After Hc2 is a normal state. Okay. From this diagram, we can differentiate this type 1 and type 2. How can we differ? It loses the magnetization suddenly, it loses the magnetization gradually. The first one, important one. Okay. From this diagram, you just refer. Okay. Here, there are two critical fields. Here, there is only one critical field. Here, Hc material Hc1 and Hc2. There are two critical fields and only one critical field. Here, there is a mixed state exists. Here, there is no mixed state. It is also one of the important point. Okay, there is no mixed state and mixed state is exist. Okay. Then one more thing is obey the Meissner effect. What is the Meissner effect? That means it repels the magnetic lines of force. It acts as a diamagnetic. Okay. This superconductor, type 1 superconductor is obey the Meissner effect. Here it does not obey the Meissner effect. That means it repels the magnetic lines of force. It does not repel the magnetic lines of force. Okay. Here the maximum known field is 0.1 Tesla. Okay, here the known magnetic field is 80 Tesla. Okay, here the example is tin, mercury, like that. Here, niobium, titanium, gallium, vanadium, etc. Okay, whenever you see the diagram, you can easily differentiate type 1 and type 2. Okay, mixed state is exist. Here there is no mixed state. There are two magnetic critical fields. Only one critical field. It is gradually decreased. It suddenly, the magnetism suddenly decreased. Okay, its known field is 0.1 Tesla. Here 30 Tesla. Example: tin, mercury. Here niobium, titanium, and also gallium, vanadium. Okay. The next class we will deal with